Hello students, welcome to Educate. In the last class, we have discussed about the nomenclature and method of preparation of carboxylic acid. In this class, we will discuss about the in-text questions which is related to the method of preparation of carboxylic acid. Let's see. First one is butane 1-ol 2-butanoic acid. So first we draw the structure butane 1-ol. So butane 1-ol is 1. This one butane 1-ol and that too butanoic acid. Where is it? Is no, not. If you have watched the earlier class, then very easily you can do. And even though if not have watched the earlier, that means just earlier classes, then also you can do. Because when you will take a strong oxidizing agent, then the alcohol will convert into carboxylic acid, and one of them is Jones reagent. Okay, what is Jones reagent? You already know if you have watched the earlier class, and if not know, then watch out the videos again and again. That means that require you to labor hard. Okay, how to do the smart work, that's I am guiding you to you already, but you will have to do the work. So Jones reagent, when you will take, then that will form. Second one is benzyl alcohol to phenyl ethanoic acid. So benzyl alcohol, what is benzyl alcohol? That means benzene is bonded to a methyl carbon, and that would be to the OH. That is benzyl alcohol or benzylic alcohol, and that structure is you will have to convert it to phenyl ethanoic acid. So phenyl here and ethanoic acid. Okay guys, how to do this question? That means in this compound you will have to add one carbon to this carbon. Then only you can convert them into ethanoic acid. If you will do directly oxidation, so benzoic acid will form. If you will do direct oxidation by taking alkaline KMnO4, then there will be formation of benzoic acid. In that, benzene will be there and COOH will be bonded to that benzene. So something else you will have to do. So what to do? First of all, convert this compound into haloalkane. And how to convert into haloalkane? By reacting with HBr in presence of ZnCl2 or like that, anything. So I am taking here, I am converting this compound into haloalkane by taking zinc and conc HCl. Recall what is Lucas reagent. Recall that. Okay, I am not telling here right now what is the Lucas reagent. This one, this form, and then after react with HCN, this compound. So chlorine will combine with this hydrogen, form HCl, and Cn minus will get bonded here. So compound will be CH2, Cn, and then after pass acidic water directly, when to the nitrile acidic water passed, then carboxylic acid form. You have studied already there. So either you convert it to haloalkane like this one, or another way is convert this benzyl alcohol into aldehyde by taking mild oxidizing agent like chromium trioside, CrO3. So take mild oxidizing agent so that alcohol will convert into aldehyde, and to the aldehyde, directly pass water to that aldehyde, react with HCN, and that HCN, I am hinting you, you do by yourself also, you try firstly. If you try and even though not able to do, then you comment in the comment box of Educat. Then after I shall tell you in detail, but right now I am giving you a hint that to this benzylic alcohol, you convert it to aldehyde by taking mild oxidizing agent like CrO3, chromium trioxide, and then after that aldehyde formed will be treated with HCN. So cyanohydrin will form, and then after cyanohydrin, and then after the cyanohydrin will form, and then after proceed the process. Next point. 3-nitrobromobenzene to 3-nitrobenzoic acid. This question is also very easy. So how to do? If on the place of bromine there should be a carbon. Firstly, your first task will be attach a carbon on the place of bromine. One of them familiar is CN, cyanide group, CN minus. So how you can replace them? So when you will react with KCN, potassium cyanide, then cyanide group will bond there. So KCN, and watch out here that nucleophilic substitution reaction in haloarine is difficult. So this reaction will take place in harsh condition. So you will have to apply the heat also. So KCN you take and add the heat. So CN will bond to this carbon. And then after here, it's how much Eg. Then after you already know that pass acidic water. So directly this compound will form. Okay, converting nitrile into carboxylic acid very easy. From nitrile, when you reduce and then after will pass water, there will be formation of aldehyde. And if you don't reduce and pass the water directly, then there will be formation of carboxylic acid. And how the ketone you can form, you do by yourself. That is, these are your homework, just like to check to yourself, which I am telling you. That is just like the homework by which you can check that how efficiently you are studying. In addition to that, these are the important points which should be in your memory, which should be in your mind. In any case, that is. So, whatever I tell you, you should do at your home. And because right now here we are not giving the test paper and like that. So, when we will provide you the test paper, then after you could check to yourself. But before that, as this is not the season of the examination, so we are not providing. First of all, our aim is to clear your concept. That's why I am discussing only about the concepts, and the work which I am telling you to do at your home, you should do at your home if you want the success, either in 12th or good marks in 12th or in CUET, NEET examination, or in IIT main as well as in advance. Now let's see. Second one is that one done. Then after is fourth one. This one, fourth. This is 4-methyl acetophenone. That too, you have to convert into. So what's the problem here? Take any strong oxidizing agent, whatever you would like. So this will convert it to carboxylic acid, and this methyl group will also convert it to carboxylic acid. So any strong oxidizing agent like KMNO4, strong alkaline KMNO4, that you will take, or Jones reagent. Keep in mind what is Jones reagent. Recall that. Next. Guys, recall that in case of ozonolysis. So when you will do ozonolysis, this carbon will convert into aldehyde and this carbon will convert into aldehyde and bond will break from here. When you will do ozonolysis, then this carbon will convert into CHO and this carbon, because to this carbon there is one hydrogen and this side is whole part, and here to this carbon also there is one hydrogen and this whole part. So when you will do the ozonolysis, so firstly this that will convert it to CHO and that will convert it to CHO, and then after oxidize them and you will get. So but even though I think that a number of guys will not solve these questions, the reason will be not that they don't know. Reason is that they will be not so much confident that they could solve this question. So that's why I am solving. But a number of students could solve these questions if they have watched the earlier videos sincerely. So but even though every students are not of the same type, so let's see. But my motive is to give the success to as much as possible to a number of guys. So let's see. I'm solving these questions here. So this form here. So let's see how to solve this question. When you react with ozone, recall that what was happening? I was telling you to take out the benzene from here, so that will be here. So this carbon here, so this one here, one side hydrogen, and here whole part. I have drawn one carbon more, so not this one. Now to this carbon one oxygen will be bonded. That is, this is carbon, this is carbon. How much carbon here? 1, 2, 3, 4, 5, 6. To one carbon, the with one oxygen, both the carbon will be bonded. With one oxygen, this with one carbon, this oxygen will be bonded. With one carbon, this oxygen will be bonded. Then after react with zinc, and then after water also. So bond will dissociate from here, bond will dissociate from here. So this oxygen will bond to this carbon, form CHO, this carbon. Here is one hydrogen also. Here is hydrogen. Keep in the mind. So either you may write, you may not write. But maybe few students get confused. That's why I have written here. So then after what happened? This oxygen will do double bond formation here. This oxygen will do double bond formation here. So carbon here and here. This is before watching, firstly write the IPAC name of this compound. I am giving you 10 seconds. Watch out. Right? Firstly the IPAC name of this compound. What is the IPAC name of this compound? Then after you will have to check when I shall write the IPAC name of this compound. So its IPAC name is hexane E retained here 1,6-diol. Okay. Now hexane 1,6-diol, and then after pass acidic water. Okay. No. To the aldehyde. Okay. No. Aldehyde form, and then after oxidize them. Oxidize them by taking CrO3. You take. So this into COH, and that will oxidize into COH. So resultant compound will be this is. Okay guys, everyone had the capability to solve this question, but a number of students was not solving this question due to their lack of confidence only. Okay. Now let's see next question. Butanol to butanoic acid, very easy. What to do? Its solution has been given. Jones reagent is what given here. So who have not studied might wish to do. So in these compounds here, maybe to a number of places, the method of preparation in this compound will be different from that of the method of preparation about which I have to solve. So depending on which method you apply, that's on that basis you can solve that. For the IIT and NEET examination, as well as for the CUT examination, because this conversion was not so much important. How to convert them, that was not so much important, but everyone should have the reactions involved during this conversion. The reactions should be in their memory, and the other few questions which I have asked you, that you reply like that. That should be in their mind. Okay. So now let's see. This one was this question solved. This question okay. Let's see here also. To benzoic acid. First question. This compound here, and that had to convert it to benzoic acid. What I have told you, that whatever be the length of this carbon chain, whatever be the length of this alkyl group attached to the benzene, when you will treat with alkaline KMnO4, there will be formation of benzoic acid always. The remaining carbon atom will release in the form of CO2 and H2O. The carbon atom bonded to the benzene, that will convert into COOH, and the other part of the alkyl group will convert into CO2 and H2O. So this CH2, this CH2 will convert into COH, and this will be into this one. So when you will take alkaline KMnO4, whereas if one dimensional question, what it is, acetophenone into benzoic acid, you will have to prepare. So let's see here. This is acetophenone and you have to convert it to benzoic acid. So very easy. Take any oxidizing agent. That ketone will convert it to carboxylic acid. A number of oxidizing agent you already know. Bromobenzene. Earlier questions we have discussed already. Here bromobenzene here, and that too. So when you get with KCl, bromine you will have to replace by Cn minus. So then after, and then after pass acidic water, as we have already discussed about that. Okay, so this is here the students, particularly the students who is in the 12th board exam, 12th class, watch out this one very carefully, and who is only preparing for the competitive examination, he will not have to appear in the 12th board examination. That guys should keep the reactions involved during this conversion. If they don't want to know that how to convert, then it doesn't matter, but the reactions involved during this conversion should be in their brain. Now let's see next one. Phenylethene, that is also called styrene. Styrene is the common name of phenylethene. So structure here. Very easy. When you do ozonolysis, a number of methods there is. You can do ozonolysis, and then after, so when you will do the ozonolysis, there will be formation of benzaldehyde, and then after pass water, or directly do the oxidation of this compound. That will be. That was about the convergence of this chapter. Next one is, okay, one topic I have left. About that, let's see firstly. About this one, structure of carboxylic group. Listen here. This is telling that in carboxylic acids, the bonds to the, okay, here this is telling that bond angle is 120 degree. Obviously here, there is no load pair of electron at the carbon. Keep in the mind also, don't be confused, that there will be distortion in the geometry of the molecule from the general trend when there will be lone pair of electron on the central atom. Yeah, if someone may consider that there is lone pair of electron at oxygen, that will shape will distort. No. there will be distortion in the shape if there will be lone pair of electron at the carbon atom. Presence of lone pair of electron at the central atom will distort the geometry of the molecule, but the atoms or groups bonded to the central atom contains the lone pair of electron or don't contain, that doesn't matter. Doesn't matter significantly about the geometry of the compound. So here bond angle will be 120 degree, this bond angle. Why? So that means every bond angle will be same. So 360 degree upon 3, that is 120 degree. So this bond angle is 120 degree. Second one is telling that in case of carboxylic acid, this carbonyl carbon, this one carboxylic carbon, this carboxylic carbon, that is less electrophilic than carbonyl carbon. Why? Because in case of carbonyl carbon, like RC double bond O, here H or R. So when this oxygen will take the electron, here will be negative charge and here positive charge. So this positive charge will utilize by this alkyl part and here by the hydrogen or the alkyl part by the plus I effect. So there will be some decline in the magnitude of positive charge. But in case of carboxylic acid, due to resonance, the positive charge of this carbon will get neutralized. Let's see here in this diagram. Okay, might be you feel difficulty in this diagram, resonating structure. So I am telling how to draw this structure. Is it clear here? Here, in case of carbonyl carbon, the magnitude of positive charge has been reduced by the plus I effect of alkyl group or of the hydrogen. And in case of carboxylic acid, let's see. There is 2 lone pair of electron on the oxygen atom. So this oxygen will attack the pi electron, here negative charge, here positive charge. And this lone pair of electron will come here for the double bond formation. So when this lone pair of electron will come here for double bond formation, so that will come. So magnitude of positive charge will be on the oxygen here. This oxygen. So what is here? This magnitude of positive charge has been declined. So out of two here, this resonating structure, in this two resonating structure here, the magnitude of here, in one of the structure, there is no positive charge on the carbon atom. So obviously this molecule will be less polar, not less polar, it will be not sufficient to tell. That means carboxylic carbon okay here. So that's just like by the inductive effect, less amount of electron supplied, and by the resonance, a large amount of electron supplies. That is here. Just like that, if you are thirsty and someone have provided you 1 glass of water and someone has provided you a jug of water, so in which case you will be more satisfied. Okay, about these questions we have discussed, method of preparation also discussed. Now let's see about the physical properties. And one of the most important properties might be, I have also told you when I was teaching you in solutions, that here, that the lower member of carboxylic acid, like this one exists in dimeric form. This one, the lower member of carboxylic acid exists in dimeric form, in aprotic solvent or in vapor phase. Keep in the mind that the carboxylic acid molecule will exist in dimeric form only in case of a protein solvent and in vapor phase, not in water. That is, any other polar solvent like water, the carboxylic acid will not exist in dimeric form. There might be dissociation of the molecule. But in case of a protein solvent or in vapor phase, the carboxylic acid molecule exists in dimeric form, because there will be extent of hydrogen bonding will be too much high. So oxygen of this acylic carbon atom is bonded to this OH part, and oxygen of this one is with this OH part. So this hydrogen bonding is, you know already, the hydrogen bonding is the strongest intermolecular bonding. So it will be too much difficult that to separate this molecule from this molecule, and as a result, both the molecule will combine together and will act as a single particle. Okay. Second one is, it is more soluble in alcohol. It is more soluble in water compared to alcohol. Why? Because extent of hydrogen bonding will be more in case of carboxylic acid. Second one is, the carboxylic acid molecules possesses greater melting point and boiling point than that of alcohol, because the extent of hydrogen bonding in case of carboxylic acid is more. Because suppose consider about this carboxylic acid molecule. Consider about this carboxylic acid molecule. So this OH part will also involve in hydrogen bond formation, that is hydrogen and oxygen, this one also, and here this acylic oxygen also. Now about this water molecule, this carboxylic acid molecule, some consider. So this hydrogen will involve in the hydrogen bond formation, this oxygen and this oxygen. So there is extent of hydrogen bonding in carboxylic acid molecule is more. Extent of hydrogen bonding in carboxylic acid molecule is more. That's why the carboxylic acids possess greater melting point and boiling point than that of alcohol. Okay, benzoic acid, the simplest. Cold water insoluble, but in hot water that will be soluble. That was. Now let's see chemical reactions. First one is here, carboxylic or the carboxylic acid shows 3 types of chemical reactions. Same as that of the 2 reactions is similar to that of alcohol. First type of reaction is reaction due to cleavage of oxygen hydrogen bond. Second type of reaction is the reaction due to cleavage of carbon oxygen bond, and third type of reaction will be due to the involvement of alpha carbon atom of the COH group. Okay, so let's see here some reactions involving here. So 3 types of chemical reactions. One is reactions involving cleavage of oxygen hydrogen bond. In that one we will have to discuss in detail. Second one is reactions involving cleavage of carbon OH bond. Third one is here reactions involving COH group, and fourth one is substitution in the hydrocarbon part. Okay, so there is 4 types of chemical reactions actually. One is due to one reactions will be due to the cleavage of OH bond. Second one due to the cleavage of COH bond. Third one is due to cleavage of COOH bond, and fourth one is due to the involvement of alpha carbon atom of the CO carboxylic acid molecules. One of the example is Hale-Bollard-Jelinski reactions. About this one, I think I have only two reactions involved in this case. Yes, one is that and ring substitution. So these are, so let's see, discuss one by one. First one is acidity. So obviously, when there will be cleavage of OH bond, the carboxylic acid molecule will act as acid. As in case of alcohol, when there was reaction due to cleavage of OH bond, the alcohol was acting as acid. Might be okay. I am telling you, just you may observe in the society that the persons who consume the alcohol, they add water or the soda in the alcohol and then after consume. If any other persons do that, if a person will not add water or the soda, maybe he complains about the burning sensation in his stomach. And why that is? Due to the acidic character of alcohol. Okay, so let's see about this one. So same as that of the alcohol, here when react with sodium, when react with NaOH, NaCO3, same, there will be cleavage of OH bond, so sodium release, so this one form sodium carbonylate, same as sodium carbonylate, but hydrogen will combine with OH and form H2O. Here hydrogen will combine with HCO3, so there will be formation of H2CO3. This H2CO3 is highly unstable, so that will dissociate into H2O and CO2. So that is the reason here hydrogen firstly combined with hydrogen of carboxylic acid, firstly combined with HCO3 minus formed the H2CO3, but that H2CO3 was unstable, so that formed the water and CO2. This is the reaction here that is showing why carboxylic acid is highly acidic, because the carbonylate ion form after the cleavage of this hydrogen oxygen bond, there will be a formation of carboxylate ion and it will stabilize them by the resonance. So that's why since the carboxylate ion is also stable, the carboxylate ion is also stable. They stabilize them by the resonance. That's why carboxylic acid is a very strong acid. Okay, now let's see. Here it is, acidic character here, how to do that. Let's see here. 12th board examination students, exclusively for the 12th board examination, if he would like to ignore this portion, then may ignore. Let's see here. Equilibrium constant, if there is, this is a carboxylic acid, if that will dissolve in water, then there will be formation of this one and this H3O plus. Equilibrium constant, concentration of product means RCO minus into concentration of here hydronium ion, that upon concentration of carboxylic acid into concentration of water, that is the equilibrium constant. The concentration of water will be here, the amount of water will be very high compared to that of the amount of carboxylic acid. So if a small amount of, if carboxylic acid will be added in the water, then there will be no appreciable increment in the concentration of water. As for example, in a jug of water, if you add 1 spoon of water, then its volume will not appreciable increase. Same here. So concentration of water is considered here constant. So K into concentration of water, this when come this side, so that will equal to This is here equilibrium constant. It is constant. Concentration of water here also almost constant. So that will be a constant. That will be called Ka, and it will be equal to. So on the place of this one, you can write Ka. So Ka will be value equal to this value. More be the value of Ka. More be the value of Ka means more be the formation of acetate ion and less be the concentration of carboxylic acid. So more be the value of K, then more acidic be the compound. So here Ka value has been given here in the compound. pKa as pH is equal to minus log concentration of H plus, or POH is equal to minus log concentration of OH minus. In the same way, the pKa will be equal to minus log concentration of minus log Ka. This one here negative sign has been inserted. Before that, you tell me 5 among 5 and 3, which one is greater? And then after, when you have inserted the minus sign, then it become minus 5 and minus 3. Which one is greater? So pKa equal to minus log Ka. So more be the value of pKa, less acidic be the compound. Okay, and what that has been given here, hydrochloric acid minus 7, put this one. So watch out here, the pKa value is how much, and then after you compare the acidic strength of hydrochloric acid and that between the acetic acid. Trifluoric acid, fluoroacetic acid, that will be the strongest carboxylic acid. Why strongest carboxylic acid? Think. If could not reply, then watch out the videos of the Educate channel sincerely, even though if cannot, that would be not, but I am considering some chances that few one will not able to reply. Then write in the comment box. The Educate channel will definitely help you. Let's see here. So that is given here. Now let's see. So that was the acidic character about that. Now let's see about that electron withdrawing group. That will decrease the acidic strength. The electron releasing group, that will decrease the acidic strength. So here no need to mugged up. No need to mugged off to this one. Okay. So let's see. About this one will be also clear for you when I shall solve the questions of exercise, and I suggest you that when I shall solve the questions of exercise questions of this chapter, then you watch out this video too much sincerely. Okay, now let's see. So this one done. Now here reactions involving cleavage of carbon OH bond. So first one is formation of anhydride. A number of times I was telling that when the water molecule, when the two carboxylic acid molecule will combine, and during that course water will release, there will be formation of acid anhydride. Let's see here. Among this one, so hydrogen of one carboxylic acid will combine with another OH, form H2O. So valency of this carbon atom become destabilized, and that of this oxygen will become destabilized. So this oxygen will get bond to this carbon. That will form. In esterification also I have discussed in the chapter of alcohol, and but even though might be someone has forgot, so about that I am discussing here. So during esterification, the hydrogen from the alcohol releases and combine with OH and form this one, H2O. So the valency of this acylic carbon atom will become destabilized, and that of this oxygen also become destabilized. So this oxygen will bond to this acylic carbon. So ester form here. How we write the IPAC name of the ester? That's your homework. Who is the sincere students who really wants to crack the IIT examination or to score the full marks in the 12th board examination will definitely do the homework, which I am telling you. These questions very easy. You can study that. If you will not understand, because a number of times we have discussed about these questions, mechanism of acidification of carboxylic acid. So next one we will discuss the here PCl5 here, same 2 hydrogen in PCl5, one reaction. Okay, all the 3 reactions should I tell? Okay, let's see. Like this compound here, when react with PCl5, so PCl5 structure is like this. The 3 chlorine atom lie on the same plane, and the remaining 2 chlorine atoms, one above and one below, that will lie here. One chlorine will combine with hydrogen, form HCl, and one chlorine will combine here. The oxygen of this one combine to this phosphorus. So when this chlorine combine to this hydrogen, form HCl. When this chlorine will combine to this carbon, acylic carbon, so that will come. And when this oxygen combine to this phosphorus, so already 3 chlorine there is. At the phosphorus there is already 3 chlorine, and 1 oxygen is getting bonded. So structure will be, okay. Usually when we write the compounds, then we write according to their electronegativity. Most electronegative towards the right and most electropositive towards the left. So that's why POCl3. With SOCl2, same here, SOCl2, like this. SOCl2 means here double bond, chlorine, chlorine. So one chlorine combined to this hydrogen form HCl. One chlorine will combine to this acylic carbon atom, and this oxygen will get bonded to this sulfur. So when this chlorine combine to this carbon, there is formation of HCl. When this chlorine combine to this carbon, there is formation of acyl halide. And when this oxygen combine to this sulfur, and already there is one oxygen, so that is SO2. Then after this, reactions with ammonia. So what happened here? In nitrogen there is a lone pair of electron. There is a lone pair of electron at the nitrogen. So this H plus will combine to this ammonia, that become NH4 plus, and here negative sign will be there. H plus here gone, so negative sign will appear here. So that's why ammonium acetate here formed. Okay. Then after what happened? Actually, a structure is like this. NH4 plus here like that, positive charge. So 2 hydrogen combine to 1 oxygen form H2O. So valency of this carbon atom become destabilized, and that of this nitrogen also destabilized. So this nitrogen will bond to this carbon. So what was happening? These 2 hydrogen was combining with this oxygen. So there was formation of H2O, and this NH2 get bonded to this acylic carbon. So compound become. So there is formation of amide here, its name ethanamide, and water. Same reactions here, NH4 plus here. Then after, the 2 hydrogen of NH4 plus combined to 1 oxygen release as water, and the NH2 combined there. So benzamide formed here. Next reactions, that reaction is too much important. This reaction here. Okay, pathalamide and pathalimide. So what happened? Benzene 1,2-dicarboxylic acid. Benzene 1,2-dicarboxylic acid when reacts with ammonia. What will happen? Same 2 molecules of ammonia will react with 1 molecule of benzene 1,2-dicarboxylic acid. Benzene, two molecules of ammonia will react with one molecule of benzene 1,2-dicarboxylic acid. So here NH4 plus, here NH4 plus. Then after, you already know that the two hydrogen of this NH4 plus will combine with one oxygen for releases water. In the same way, two hydrogen of this NH4 plus will combine with one oxygen and release as H2O. So NH2 will get bonded to this carbon and NH2 part will get bonded to this carbon. So that's why here amide, here amide. So its common name is, IPAC name will be benzene 1,2-diamide, but common name is phthalamide. Keep in the mind here. Here common name is phthalamide. Amide it is, AMIDE. After that, what happened? This NH2 will combine with one hydrogen of this NH2. Here I am showing the structure. In these molecules, either one hydrogen of this nitrogen will combine to this nitrogen and releases ammonia, or hydrogen of this nitrogen will combine with this NH2 and releases ammonia. So hydrogen of this NH2 will release, or hydrogen of this NH2 will release. That will depend on the matter of chance. You cannot say that from which amide the hydrogen will release and from which acylic carbon atom the amino group will release. That will depend on the matter of chance. So here hydrogen combined to this one. So what happened? That releases as ammonia. Then after, the valency of this nitrogen atom and that of this acylic carbon atom, both will be unstabilized. So this nitrogen will get bonded to this carbon atom. So that's why the structure here that will be here. So this benzene, here is one acylic carbon atom, here acylic carbon atom, and here nitrogen, and that is bonded to this carbon, and nitrogen is already bonded to this hydrogen. This one is called phthalimide. So keep in the mind here, it is amide, E, and here imide, I. That's the difference. Only bigger difference in the name of the compound, and that bigger difference will create a lots of differences. So that is phthalimide. Okay. Then after the reduction, so obviously you have already studied that when alcohol will oxidize, then aldehyde, and then after, if alcohol will oxidize by taking a strong oxidizing agent, then there will be formation of carboxylic acid. And when, so like that, when the carboxylic acid will reduce by taking a strong reducing agent, there will be formation of alcohol. So here a strong reducing agent AlH4 has been taken, and this one formed. Next, that is reactions involving COH group. It is. Next one is here decarboxylation reaction. What happened here in decarboxylation reaction? The mixture of NaOH and CaO in the ratio of 3:1. That is called soda lime. The mixture of NaOH and CaO in the ratio of 3:1 is called soda lime, because NaOH is called caustic soda and CaO is called quicklime. So their mixture is called soda lime. What happened during this reaction? So during this reaction here, from this portion NaO that combined with whole of this functional group. That's mean NaCOO combined with NaO. So 2 sodium, 1 carbon and 3 oxygen. So 2 sodium, so Na2, 1 carbon, so C, and oxygen 3. So that's why there is formation of Na2CO3. Hydrogen left here. The valency of this hydrogen left, and here carbon atom also. So this hydrogen will combine to this alkyl part. So there will be formation of alkane. So when the carboxylic acid will react with, the soda lime, there will be formation of alkane and the sodium carbonate. Okay, halogenation reaction. So about the Hale-Bollard-Zelinsky reaction, keep in the mind here that halogen is taken in presence of red phosphorus and water. What happens? This halogen will combine to this alpha carbon. So to this alpha carbon, halogen get bonded. That alpha carbon, this halogen should maybe chlorine and bromine. That will be only. So that is this name reaction. So this name reaction is quite important for you, for all the format. That is for 12th board examination, for CUET, NET, as well as IIT main. Next reaction is ring substitution. You already know that in a ring substitution, COH, that is electron withdrawing group, it is not electron releasing group as in case of aldehyde or the ketone. The acylic carbon atom was electron withdrawing group. So see, in the same way here, this one is electron withdrawing group. So it will give position to the electrophile only at the meta position. So at meta position, the NO2 group has been bonded. Same when halogenation is doing in presence of a Lewis acid, maybe FeCl3 or any other one. So when the halogenation of benzoic acid will be done in presence of any Lewis acid, there will be formation of, that means this bromine will bond to meta position. So there will be formation of meta-bromo benzoic acid. Okay guys, that was about, and of the remaining part, something here, because this chapter here, size of this chapter is quite important. So we will also discuss about that, but that will be in the next class. Thank you, Team Educate.